All right, y'all, today we are going to go over some key features of graphs. A lot of this will be review, hopefully, but I would love it if you wrote it all down, and it will be very, very helpful on your assessments if you write it down. Okay, so relative versus absolute maximum and minimum. Make sure you get the notes title, 1.6, Key Features of Polynomials. And let's go ahead and start with relative versus absolute maximum. All right, so relative maximum, you'll want to write down all of these terms and their definitions or meanings. So relative maximum, the relative maximum is all of the high points on the graph, or I'm going to say on the curve, the function, all of the high points on the curve. And make sure you recognize that this is plural, so there could be more than one. And then relative minimum, all the low points on the curve. And again, it's plural, there could be more than one. The absolute maximum is the highest point on the curve. And that means there's only one. The highest point, only one on the curve. And then the absolute minimum is similar to absolute max, the lowest point on the curve. And there's only one. Again, for absolute, there's only one. And then for relative, there's two possible relatives. Okay, or not two, sorry, multiple. As many as you can find. All right, so let's find some. Let's go to a graph, an example graph, and I would love it if you draw this graph quickly in your notes. You do not need all of the x values. When you draw example graphs, please just get the like where you cross. So this crosses at -3, at 0, x equals 0, at 1, and at 3. You don't need to like draw the perfect graph. And then make sure you have your arrows on your ends. And yeah, let's go ahead and get started. Also, you'll want to write down -3 is where this happens, this low point. And let's say that this is like 1/4 where that high point happens. Let's say that this is, let's just pretend that this is at -1. -1. Okay. All right, let's get started. So, the first thing we need to write down are the relative maxima. And again, there are going to be multiples because you can have more than one maximum. Well, there doesn't have to be a multiple though. So what we're going to do is we're going to check for all the high points. I like to think of this as like the hills. Look for the hills, the tops, hilltops. Okay, so for maximums, it looks like we only have one hilltop, and we need to write the actual point. So this happens at 1/2, x equals 1/2, 1/2, and y equals 1/4. So that's what we're going to write for relative maxima. 1/2, 1/4. There was only one hilltop, so we're only writing one. And then make sure that you know you are supposed to write these as points. All right, absolute maximum is going to be the absolute highest point on the graph. And for this graph, let's only look between -3, only between negative and 3 and 3. We're not going to pay attention to the arrows right now. So the absolute max between -3 and 3, so like this is our zone to look in, it would be that relative max. It's the same number. So we're going to write that point down again, 1/2, 1/4. Okay, now let's do our relative minimum and absolute minimum. So relative min, again, there can be more than one. And this time we're going to look for the valleys. Valleys. between -3, x equals -3, and 3. We're looking at the valleys, and here is one valley, here is the other valley. So we're going to say this first valley happens at x equals -2, so -2, and y is -3. And then the second valley happens at like 2, let's call that 2.5. I know it's not perfect. So 2.5, you can write 2.5 if you want. We'll use a decimal in this case. And then let's say that y is -1. It's not perfect. So all of the minimums, or the relative minima, are -2, -3, and 2.5, -1. Okay, so really quick, let's make sure we know the actual minimum and maximum are the y values. Right now we're writing down the points where they happen, but the heights is really what we're looking at, the y values. So if like a question asks, what is the minimum? The minimum will be your y value. You're going to look for the actual y value where those points happen. Okay, cool. So let's see. Absolute minimum is going to be the lowest point on the graph. That's -2, -3. This one, right, is the very lowest point on the graph. There's only one of them if it's absolute. And you can say like min is -3, right? We could say the max is 1/4 because that's the y value, the height. Max is 1/4. Okay, now let's move on to a different topic, domain and range. And again, I'm hoping that this is all review for y'all. Domain is all your possible x values. All possible x values. Range is all possible y values. So make sure you know that. And we are going to find the domain and range of two example functions. So get these down. And it's important again to have like where you cross the x and y axis on your graph, and then also draw your arrows. Okay, and we're gonna write a little like important note to ourselves here. Always write domain and range. Always write these least to greatest. So smallest number comes first, and then bigger number comes last. And I'm going to show you two notations for domain and range. So let's do domain for both of these functions first. All right, so domain is all the possible x values. So here's the thing, y'all. The first thing we need to talk about is these arrows. Arrows, these things, these always actually point two directions. They look like they point one direction, but they'll always point up or down. So like for this first set, those arrows are pointing obviously up, right? But then in the second set, the arrows are pointing down, right? But then the thing is, people don't know always that they have to point left and right too. So I want us to annotate our arrows. What are these pointing? So like this arrow over here, is it pointing left or right? It is pointing a tiny bit left. See how the like line is angled left? So we're going to annotate that arrow and it points a little left as well. And then the arrow over here, well, that function, this curve is leaning a little bit to the right. So that arrow also points right. Arrows always point two ways. Let's do this one over here. We're going to annotate this arrow. It is pointing down and left. And then let's annotate this arrow over here. It is pointing down and right. So annotate your arrows when you're doing domain, range, increasing, decreasing. Annotate your arrows. And let's get domain down now for these functions. X values. All your possible x values is domain. This is your x-axis, right? On both of these graphs. We'll stick to the first graph for now. And you need to look at your arrows when you're doing domain and range. X goes this way, left and right. Your x-axis goes left and right. So we're going to look at the arrows that are pointing left and right. And how far left do these point? How long do they go to the left? How long does this function go to the left? Forever. The arrows Arrows mean forever. Forever. Okay, so if this is going forever to the left, that's going to go to negative infinity in the x direction, right? So I'm going to put negative infinity over here on my x-axis. That's like forever to the left. What about forever to the right? Positive infinity. So my domain, you're going to go least to greatest. Remember, least to greatest. So my domain goes from negative infinity, that's the smaller one, and then x is in between negative infinity and positive infinity. That's how we write our domain. We can also write it in interval notation, so I'm going to show you that. You can also write negative infinity, comma, positive infinity, and then infinities always have parentheses. That kind of rhymes, so I try to remember it that way. Infinities always have parentheses. Okay, let's do domain for the second function. So again, you need to look at your arrows for domain and range. Where is this arrow on the, like in the x direction pointing? Well, they're pointing forever left and right again. So this goes to negative infinity on the x-axis. This goes to positive infinity on the x-axis. So your domain's actually the exact same for the second function. It's negative infinity is less than x is less than positive infinity. And infinities always get parentheses. Another way to write this is negative infinity to positive infinity. All right. Let's see. Another way that you can read this is like x is in between negative infinity and infinity. All right. Let's continue range. Range is my y values. So when you're looking for domain and range, you're looking for all the possible y values. You are going to look at your arrows. So what's my highest y value over here on this function? What is my highest y value? Well, my arrow is pointing up. So that's going to go forever in the positive direction up. That's taking me to positive infinity. So on my y-axis, I'm going to positive infinity on this function. But what about my lowest y value? Remember, we need to write from least to greatest. So we need the lowest y value first. Well, let's look on our y-axis. How low does this function go? Right here. That's the lowest spot. What is the y value for that spot? Negative 3. So my lowest y value is negative 3, and my highest y value is positive infinity. So we're going to write the range. X is in between negative 3 and infinity. Okay, really quick. We need to talk about the difference between like less than or equal to and less than, and the difference between parentheses and brackets. So less than, on the first example that we had right here, we had only less than because you can't equal infinity. It's impossible. But can we equal negative 3? Yes, we can. We need to check though, does our function actually ever touch y equals negative 3, or does it actually get that low? Is there a point on the curve at that y value? So here's the thing, y'all. If your function like comes and touches that y value, if it meets that height exactly, then yes, there's a point there, and it equals, your y value actually equals negative 3. So we need to put on our range, we need to put an equals, less than or equal to negative 3. And then instead of writing a parentheses, now we would write a bracket. If it's equal to, you write bracket negative 3, comma, infinity. Infinities always get parentheses because you can't equal infinity. Okay, let's move on to the range of the second function. So we need to go least to greatest. So let's start low. How low do we go on the y-axis? On the y-axis, how low do we go? Well, look at your arrows. This is going down to negative infinity. The arrows are pointing down forever. So we go all the way down to negative infinity. How high do we go? We go all the way up to positive 3. Do we equal positive 3? Does my function actually like make it to positive 3? Yes, it does. So it equals positive 3. So we need to write our range from least to greatest. So start with a smaller number. Negative infinity, that always just gets a less than sign. X less than or equal to positive 3. because we get as high as positive 3. And we could write this parentheses, negative infinity, because infinities always get parentheses, and bracket on the 3 because we actually have a point at x equals 3 up here. Okay. All right, let's move on. Increasing, decreasing, and we are over halfway through. So keep up the good work. We are getting close to being done. All right, increasing. A function is increasing if it looks like this. And increasing has positive slope. So write that down. An increasing function has positive slope. A function is decreasing if it looks like this, and it has negative slope. And then a function is constant. A function is constant if it looks like this. And then slope equals 0 for a constant function. All right. We need to write the intervals. We need to write the intervals of when these functions down here are increasing and decreasing. I want you to make a note to yourself. Intervals means x values. We're going to write the x values on which our functions are increasing and decreasing. Okay, so the first thing I'm going to do is draw kind of like little arrows on my function. Oh, remember to read your function left to right. So put a little note, read function left to right. That's like how we read words, right? We start on the left side of the word, we start over on the left side of the word, and we read to the right. So we go this way. When we read words, we go that way. So we're going to do the same thing with functions. We're going to start on the left side, and we're going to read it this way to the right. So always start on the left. And I'm going to put little arrows where we are increasing or decreasing. So we are starting on the left side of this function. And is our slope positive or negative here? It's negative. It's going down. So I'm going to like draw little arrows. We're going down. One way I like to think of increasing, decreasing, if you're a fish and you're starting on the left side of your function, because we always go left to right, and you're swimming this way, are you swimming up or down? We're swimming down, 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 all the way to here, right? And then our fish starts swimming up. So then we're increasing. Increasing. Uh-oh. Then our fish starts swimming down again. And then starts swimming up again. Okay. So now that we know where we're increasing and decreasing, we need to write the intervals. Remember, the intervals are the x values where you're increasing and decreasing. So we need to look at our arrows again. So let's annotate our arrows. Make sure you always annotate your arrows. Okay, when did this fish start swimming? Well, this arrow goes all the way to the left, right? Forever. So our fish started swimming at x equals negative infinity. All the way to the left, at x equals negative infinity, we started swimming, and we started swimming this way, but we were swimming down because we have green little arrows. So, when did our fish stop swimming down? At what x value? We started swimming at negative infinity, and then we kept swimming, swimming, swimming. At the x value negative 2, we stopped swimming down, and we turned around and started swimming up. So our first interval of, oh shoot, we were talking about decreasing. So let's go ahead and write that one. Our first interval of decreasing goes from, I'm going to do the brackets and parentheses one just for speed to make it go a little faster. So we started swimming down at negative infinity. These are x values. Remember, these are x values. Infinities get parentheses. And we stopped swimming down at x equals negative 2. For increasing and decreasing, we can make a note, always use parentheses. Always use parentheses. Parentheses for increasing and decreasing. Or these, no equal to, just less than or greater than. Okay, so we're decreasing from infinity to negative 2. Well, there's another area where we are decreasing, right? Right here. So we're going to write and, but we're going to write the math version of and now let's write where that happened. where did we start going down again? At like x equals 1/2. 1/2 to x equals 2.5. 2.5. Sweet. Okay, that's where we were decreasing. Let's write where we were increasing. We started increasing at -2. X equals -2 was where we started increasing, right? -2, comma, and then where did we stop? Right here at x equals 1/2. And there's another spot where we were increasing, where our fish was swimming up. 2.5 is where we started going up again. 2.5, comma. And then what x value should I use on the right-hand side for the far right? Well, remember, these arrows are telling me we went forever to the right. So we just kept swimming up to infinity. And that's our interval of increase. Okay, let's see. I'll do one more. Increasing, decreasing. Let me draw my little arrows. Remember, you're going from the left to the right. So we are starting on this side. We're going up, 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 up. We have positive slopes all the way till there. Then we transition to going down, 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 down. Okay, let's write our intervals. Remember your arrows. Annotate those arrows. They're always pointing in two directions. We started swimming up at x equals -infinity all the way to the left. And we stopped going up at 1. And then we started going down at 1. We started going down at 1 and stopped going down. Well, we didn't ever stop going down. We went down all the way this way on the x-axis, which is positive infinity. So 1 to infinity. Okay. And then here's where I got the 1 from, by the way. Right there. That's where we switched on the x-axis. Remember, you're using x's for these. All right, we have one more thing. Positive and negative. Positive and negative. So, positive is when you are above the x-axis. Negative is when you are below the x-axis. So on this same graphs that we've been using, we're going to talk about where are we positive and where are we negative. Okay, positive is when you're above the x-axis. You could think of, I like to think if we're going to use the same analogy, the fish, think of this as water. Positive is when you're up in the air. Your fish is up in the air. Negative is when you're down underwater. Okay, so where are we positive? I will highlight it in yellow. We are positive above the x-axis. A positive above the x-axis. And we're negative below the x-axis. Oh, I missed a tiny little section that we were positive. Right here. Okay. And we are again going to use the x intervals to describe where we're positive and negative. And anytime you're using intervals, you need to annotate your arrows. So these arrows go up forever, and then you have to pick left or right. This one goes down forever, left forever, down forever, right forever. Okay, and let's write our x intervals where we're positive or negative. So we are positive in the yellow. Start on the left. Start on the left. How far left does this function go? Look at your arrows. It goes to negative infinity. So we're positive from negative infinity to, and then what x value do I switch to being negative? At x equals -3. So we're positive from negative infinity to -3. You're going to use parentheses again for these. We're also positive right here at x equals 0 to x equals 1. So and 0 to 1. And there's another space that we're positive, so we're going to say and then let me write the point, 3, or the interval 3, x equals 3, to how far to the right? Positive infinity. So 3 to infinity. All right, let's do positive for this other graph. It looks like we change over to positive at like -3/4. X is -3/4 right here. And then 2 3/4, 2 3/4, maybe right here. That's what x is. So we're going to say positive from negative 3/4, oops, 3 over 4, to 2.75. Or you could say 2 3/4. Okay, let's go ahead and do negative. So where are we negative? On the first graph, we are negative from x equals negative 3 to 0. And there's another spot. X is 1 to x is 3. All right, and then on the second graph, we are negative. Well, how far to the left? Remember, you have to start on the far left. This goes all the way to the left, negative infinity. So we're below the x-axis from negative infinity to 3/4 is where on the, negative 3/4 is where on the x-axis we switch to positive right here. And then we're negative again, and 2 and, that's supposed to say 2 3/4. 2 3/4, or I wrote 2.75 above, 2.75 to, how far to the right does this function go? Positive infinity. Okay, that is it for today. I know that was a lot. It should have felt like a review, I believe. If you're struggling with it, please let me know and potentially rewatch this video. All right, let's do some practice.